Good morning, my dear kids. Today we are going to discuss our fourth Google form based on Unit 4, Grade 10, Newton's Laws of Motion. I hope that you all have already submitted your Google forms now. Okay, Putta, we will move to our first question. What is the standard unit of force? Unit of force is defined as the force required to produce a unit acceleration in a body of unit mass, and it is equal to 1 unit. In here, F is equals for M into A. In this case, as a SI unit, we are now using Newton. Actually, there are 3 Newton's laws of motion. From that, first law is such a simple concept. As given in here, an object at rest will remain at rest unless a net force acts on it. Or otherwise, in another opinion, an object in motion will remain in motion unless a net force acts on it. It's such a simple concept. That means if something is in rest, it will keep on resting. If something is moving, it will keep on moving unless an unbalanced force is not on it. Okay, our second question. The following are 4 instances about several objects are existed. Among these statements, Newton's first law can be explained by, first law means what I have explained you earlier. First one, a fruit falling from a tree. In there, Putta, actually they have that unbalanced force, gravitational force. Next one, traveling a spacecraft. C, parking a train at a station. That means it's a stationary thing. Ascending a balloon filled with hydrogen gas. In here, the answer is B and C. Question number 3. What is the law that explains the falling of passengers forward when the driver of a moving train applies the brake? Here, this is actually an incident which we all have faced with. In here, in figure 1, figure 2 and figure 3, this shows you a man who is in a train and the train is in its motion. In the second one, the train applies brake at once and the train comes to the board. In here, the passenger, the man, the passenger, it's forwarding back. Since the passenger in contact with the flow of the board, that means in here, Putta, the floorboard exerts a resistive force on the feet and brings the feet to rest. In here. Since no such force is exerted on the upper part, that force is not in the upper part, no, Putta. Their velocity carries him forward. This part, it has its own velocity and it carries him forward. He falls in the forward direction because of this. Question number 4. An instant where Newton's third law of motion is applied. Actually, the Newton's third law, it's a very short one. It tells you for every action, there is an equal and opposite reaction. So, in here, tug of war, motion of a satellite, carrying a baggage, and rowing a boat using oars. In here, the answer number 4. The answer number 4 tells you when rowing a boat, water is pushed in the backward direction using the oars. That is, a force is applied on water by the oars. Then the boat moves forward due to the reaction force applied on the oars by water. Actually, in here, Putta, just keep this in your mind. The boat moves forward due to the reaction force applied on the oars by water, not to the boat. Question number 5. In physics, the momentum of an object is defined as the product of the mass and a blank of the object. Now we are going to fill in this blank. An easy thing. You know what is this? The momentum. Momentum means, this is the equation, Putta. Momentum means mass into velocity. The momentum of a moving body is a measure of how difficult it is to stop the motion of a certain moving object. Level of this difficulty in stopping a moving body depends on two factors, mass and the other one is velocity. So in here, Putta, the blank will be filled with velocity. What is the most appropriate definition for the force of attraction of a mass towards the earth? Here there are two words, what you call as mass and weight. Actually, when you were just small kids, when you were in grade 4 or 5, you have talked about this mass. But when you come to grade 6, 7, 8, another word comes as a weight. So in here, in science, Buddha, mass and weight, it doesn't mean the same thing. It has two different definitions. The mass of an object is the amount of matter in an object. The international unit of mass is kilogram. But when you come for the weight of an object is the force with which it is attracted to the earth, in here, to the earth. That is the force acting on it due to the gravitational attraction of the earth. So in there, Buddha, the SI unit of weight, though the weight is a force, the SI unit is Newton. So according to this, the force of attraction of a mass towards the earth, it's going with the weight. What is the force required to give an acceleration of 3 ms minus 2 to a 10 kilogram mass? In here, Buddha, this means 3 meters per square seconds. 3 ms minus 2 means 3 meters per square second. In here, 3 meters per square second, this is the acceleration. So you have to enter that data to A. Then you have given mass as 10. So 10 into m, it will be 30 Newton. In science, you have, when you get the marks, Buddha, the equation, we are giving marks for this equation. So please keep that in your mind. You have to write the equation. That is the most important thing. Number 8. What is the acceleration of an object with a mass of 5 kilograms traveling at a given velocity by applying a force of 20 Newton in the direction it is traveling? Number 9. If a force of 12 Newton is applied to an object at the acceleration of that object is 2 ms minus 2, that means 2 meters per square second, the mass of that object is same as which you have in the previous one. F is equals for m into a. In here, Buddha, they have given you the force. F is given as 12 and they are asking you the M and you have to go for the acceleration as 2 meters per square seconds. So in here you have to make M the subject, and when you make M the subject, 12 will be divided by 2 and it will be 6 kilogram. Number 10. If a car with a mass of 1,500 kilogram travels at a velocity of 10 ms minus 1, what this mean? 10 meters per second. 10 meters per second. What is its momentum? It's very easy to that. Yes, you have to write P is equals for M into V, the equation for momentum. Then simply you have to use 1,500 as M, V as 10, and you will get the answer as 15,000 kilogram meters per second. Okay, this is the summary that you have in your textbook. I will just go through this one today. According to Newton's first law, until an unbalanced force acts on it, a stationary body remains at rest and a moving body continues its motion at a uniform velocity. So this is what I told you earlier as resting things keep on resting. The moving things keeps on moving until they meet with another unbalanced force. Second law, there you have the acceleration of a body is directly proportional to the force acting on it and inversely proportional to its mass, what you call as F is equals for M into A. Third law, most fantastic one. For every action, there is a reaction, equals in magnitude and opposite in direction to the action. It's a very simple one, but there's a very deep emotional feeling in that one. The weight of an object is the force which it is attracted to the center of the earth, what you call as the gravitational acceleration. According to the gravitational acceleration, you have your weight. So this is the summary of the unit number 4, Newton's laws of motion. So Puta, stay curious. Always when you are learning science, be curious. If you have something to ask, please ask and listen to the others. It may be your teacher or it may be of one of your friends or the elders, and get solved. That is the most important one. You have to be curious. Then you have to have some methods to clarify that thing and you have to solve your thing. Okay, Putta, thank you and good luck.